Mr. Sams? What are you doing?
What do you mean?
It looks like you're sticking styrofoam balls onto your face.
I am.
And that would be because...
And onto the rest of my person.
And they're falling on the floor.
I'm making them bond to me. I'm making chemical bonds.
Bonds. Chemical bonds.
Yeah, sure.
That is what we're going to talk about this time. We're going to be talking about chemical bonds.
Came off.
So people, Mr. Sams obviously needs help.
I need more tape.
He needs more tape. He needs more help. He needs more help to do this. So I think you need professional help. I have a counselor friend.
Oh yeah?
Yeah. Maybe I'll get Miss Wilson in here to come help you because obviously you need some deep counseling.
Nah.
Yeah.
Just bonds.
Yeah.
Chemical bonds.
Well, I guess we are talking about chemical bonds.
We
so
are.
I guess we should probably start talking about chemical bonds.
All right.
Okay, let's do that. Well, seriously, folks, we really are going to be talking about chemical bonds. And Mr. Sams, as crazy as he is, we have no idea where his brain is today.
I don't know what you're talking about.
So, podcast 8.1. Types of bonding, electronegativity, bond polarity, dipole moments, ionic size. We're going to talk about all these things. All right, so this is the beginning of chapter 8 in AP Chemistry, using the Zumdahl text, by the way. And that would be the 6th edition. You got styrofoam in your mouth.
Yeah.
What were you eating?
I was not eating styrofoam balls. It was out of my mouth.
You need help, folks.
I've been hanging around
Listen
with my 1-year-old daughter
carefully. He needs desperate help.
Anything that's on the floor.
Miss Wilson, come save us. Okay, so here is the schedule for everything for this chapter. 8.1. This is actually these sections in the Zumdahl textbook. Even though we call it the 8.1 podcast, it actually is like 8.1 through 8.4 in the Zumdahl book. Okay, so with that said, let's talk about bonding.
All right.
Folks, do you realize there are 3 main kinds of bonding? And many of you have seen a chart like this before, but we're going to talk about this. There is ionic bonding, there is covalent bonding, and there is metallic bonding.
And then there's tape.
And then there's tape. There you go. Ionic bonding, what's the story on ionic bonding? That is a bond between a
metal and a non-metal.
A metal and a non-metal. Covalent bonding is a bond between a
2 or more non-metals.
A non-metal to a non-metal. And a metallic bond would be a metal.
Metals.
And then covalent bonding has these things called polar, non-polar, and that's a London dispersion force, hydrogen bonding, dipole forces, and we're going to get into this in great detail as we progress in this particular unit. This unit, by the way, encompasses chapters 8 and 9 and then part of 10 in our textbook. So that's where we're going to kind of finish up with. Now, we want to first start talking about what holds everything together.
Tape.
Tape. There you go. Tape holds everything. Duct tape
Duct
solves.
tape specifically.
Yes, indeed. We've got our peanut gallery over here. Isabeau's helping us out today. Okay, and the key thing actually, it's not tape that holds everything together.
Really?
No, it isn't. It's actually Coulomb's law.
Oh.
Yeah, there was this dude named Coulomb, and he made a law. And
Hence
they called it Coulomb's law. Yeah. And basically he said that if you have 2 things with charges, and Q here stands for charge, Q1 and Q2. And then R is what?
The radius or the distance between them.
So you have 2 objects that are close together. They are attracted together with a particular amount of energy equal to KQ of R, where the value of K is this particular number. And the Q is like the charge. So if I have, for example, like sodium and chloride, which is Na positive and Cl negative, Q1 would be positive 1 and Q2 would be a negative 1.
Negative.
And hence that gives you the answer.
I guess there's no T in there, so there's no tape term.
I don't see T's in there.
No. Okay.
I'm thinking not.
All right.
So what actually holds things together is...
electrostatic attraction? Is that the
Yeah.
word you're looking for there?
That is right.
All right. There's static in tape.
Yeah.
If you put 2 pieces together and pull them apart,
There
you
you
get all
go.
staticky, right?
There you go, and then you can create this electrostatic attraction.
Okay.
But basically what electrostatic attraction means is that positive things are attracted to negative things. Now why is that, Mr. Sams?
Because opposites attract.
Why do opposites attract?
Makes life more interesting?
Yeah, I guess so.
No.
The actual answer is, from a scientific perspective, is we really don't know.
Yeah.
This is where string theory comes in and all this interesting stuff that basically, why is that the case? And of course, you probably also know, if you ever play like a magnet, if you take a positive thing and a positive thing, they actually repel. Why is that? We really don't know.
They just do.
They just do. We do not know the answer to that question. It's one of those questions of why are the fundamental forces, and we don't know.
We don't know.
But we can measure it, we can use it to calculate things, etc., etc. So we know the strength of it, but it's an interesting thing. All right, let's talk about ionic bonds, okay? Now, in an ionic bond, not diagram, just ionic bonds, what do the electrons do?
They are transferred from one atom to another atom.
So that's the key thing in an ionic bond. So now we're going to focus a little bit on ionic bonding for a few minutes. Is in an ionic bond, there's a transfer of valence electrons. Actually, I need a blank page, so hold that thought. All right, so what I'm talking about this is when I have a... All right, so if I've got sodium, sodium has one valence electron.
Yes, it does.
Now, we haven't really done Lewis dot structures, but most of you have seen this kind of a concept before. And say chloride has 7 valence electrons. Okay?
And everybody wants 8.
Remember that rule of 8, octet rule. And so the sodium wants to give away 1 electron, so he ends up with 8. I know it sounds like he'll have 0, but actually have 8 on the center layer.
Yeah, the next layer down.
If you were to draw a sodium ion, or sodium atom, you would have 8. This would be what one of the shells, and then another shell would have 1.
That's where the 1 is, yeah.
And that's the 1, and this is the 1 that's going to be given over to the chloride. And then the chlorine, actually the chlorine wants 8, and so when everything is done, when he loses an electron, something happens. What happens?
He gets a positive charge.
Now, why does he get a positive charge?
Because electrons are negatively charged.
Well, Mr. Sams, I have a problem.
Oh, you have a marker on your head.
Well, it's
Wait.
it's actually an electron. Oh,
Let me help you.
I gotta have
Hang on a
this thing.
sec.
Ow!
There.
Oh! It's in my eye. Okay, we got it. All right. So I have a problem.
What's your problem?
I have a marker stuck in my head.
Yes, you do.
But it's an electron. And you see, I do not really want this electron.
Okay.
Because you see, I have an extra electron, like the
Okay.
sodium atom.
All right.
Got the idea?
Okay.
And you really want...
I want that electron.
You're the tape guy.
Yeah.
You're the tape guy. So what would you do if you were like a chlorine atom?
I'm going to try to get that marker and I'm going to tape it to my head.
I think you actually need to take it.
I think I'm going to take this marker. Ooh,
And put it on you.
I don't want your nose grease taped.
Oh, have mercy.
I'll get my
Actually,
own, put my
that
own
felt
nose grease.
really, really good. Because you see, I wanted to get rid of that
You did.
electron. And guess what happened? You wanted to take the
I
electron.
did. Now I'm going to take it and tape it on my nose.
You see, by the way, you know when I had that nose, my nose with the marker on my head, I didn't feel very positive about myself. I felt pretty bad.
Because
But
you
you
had
see,
a marker on your
because
head?
electrons are negatively charged, and so when I gave you my negatively charged electron, or you took it, I feel really good about myself.
So you feel
I feel
Positive.
positive. And of course, you took my electron away from me, so you feel
negative. I'm feeling kind of guilty. Yeah. So,
you're feeling pretty bad
yeah,
that you took it.
that
from
I
me.
took it.
Yeah,
and
and you
that
get the idea.
That I look pretty ridiculous.
So, folks, you
now,
get
too.
the idea.
Yeah.
Is he took the electron from me.
Yep.
And now he feels very negative because, of course, he looks ugly. He's ugly anyways. And so you see, I feel positive because I got rid of the ugly nose. Now he's the ugly one. I was ugly, now he's ugly. You get the idea? All right, I think we get the idea.
And I got to use tape, too.
Okay, so Mr. We're back again live on Better Precision. Okay, so what actually happens is the sodium then, picture 1, and we have picture 2. The sodium now has a positive 1 charge. That was me, of course, the good-looking guy, because I feel positive. At least I felt positive. And Mr. Sams gets that extra electron. So instead of having 7, he now has 8. And here's the 8th one right there. And he has a negative charge. Now, what happens now with the sodium? Why does the sodium connect to the chloride?
Because opposites attract.
Yeah, so positive attracted to negatives. Actually, if we would have taken our analogy further, we should have like hooked up together. And that sounds wrong. Yeah, that is wrong. Okay, covalent bond. Now, in a covalent bond, something else happens. What goes there? That's called
That's where they're sharing.
Oh, it's a very nice. It's like when in kindergarten you learned how to share. So they share valence electrons. And when they share, we could say, for example, take chlorine and say chlorine. So chlorine has, as you call, Jim, just a minute ago, 7. And you see, they want to have 8. And so if they could share that extra 1, maybe a circle around all of them, he now has 8. And if I go like this and he shares that one, he has 8.
So, and then the overlap is going to be the covalent bond, the sharing of those two electrons.
So you would actually draw it like this. You'd say Cl line, Cl. Now that line, this line, is equal to those 2 electrons that are shared. And then you would have the additional electrons. And now we haven't done Lewis dot structures. I believe that's the next podcast or something subsequent. But I want you to get the idea. They share, and that's what makes the bonding.
Sharing is caring.
Share.